Today we're going to look at adding two fractions that are less than 1. We're going to do it with a model version so that we can see visually what's happening with that math. First, I've got two fractions here. I've got 1/3 and I've got 2/5. They both have different denominators. When we did this traditional math method, we would find a common denominator, convert them into new fractions, equivalent fractions using that common denominator, add the numerators, and then simplify the fraction. I'm going to show you how to do that with a visual model. I'm going to start by drawing a grid that will allow me to model both of these. If I was going to model my first fraction, 1/3, I would divide this into 3 equal parts. One way we might have done this in the past would be to color in 1/3 and show that. Something like this. Okay? So 1/3 of this is colored in. Instead, though, I'm going to actually model both of these fractions in one grid. So now I'm going to divide the array into fifths the other direction. So I do that by drawing 4 lines across. Now I've got an array which has thirds going this way, 1/3 here, 1/3 here, 1/3 here, and fifths going this direction. So if I were to fill in one whole row here, or one column, sorry, there would be 1/3 filled in. If I was going to fill in 1/5, I would fill in one whole row. So using my grid, I'm going to do counters. I'm going to represent 1/3 using these red counters, or black counters with the red trim, and I'm going to show my fifths using these blue counters. So if I was going to fill in 1/3, I would fill in a column like this. Then I was going to show 2/5, I would have to fill in the columns going this direction. There's 1/5, and there's 2/5. So now I have 1/3 of my columns filled in, and 2/5 of my rows filled in. My only issue is that I've got these 4 sharing 2 boxes. So to count them individually, I'm going to have to move them. So I'm going to take this blue counter, and I'm going to move it to its own space, and move the other one to its own space. Now I can find out how many I have altogether. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of a total in my grid of 3 by 5, which would be 15. So my fractional notation answer for this addition problem would be 11/15. If I was going to show that in traditional method, I would look at the thirds and the fifths. My common denominator would be 15, so I would have some 15s plus some 15ths, and I would see what I need to do. 3 to 15 was times 5, so I'd have 5/15, and the equivalent fraction of 2/5 would be 6/15, which added together would be 11/15. So you can see that we have the same result, the traditional method, the algorithm, with our model method. The model method just shows visually how we can find that common denominator and what's happening behind the math when we find the equivalent fractions. Now I'm going to apply that same strategy into adding mixed numbers. So here I have 1 1/4 and 2 1/3. So I'm going to draw my 2 models of these fractions very quickly. So what I've set up here, I've only shown the whole numbers so far. So 1 I've shown in red here, 2 I've shown in blue, down here my 2 wholes. Now to combine the fractional parts, the parts of the mixed numbers less than 1, I'm going to combine them into one grid together. So I'm going to draw my next whole here, and again I'm going to use my fourths, my denominators, and my thirds, my denominator here, to divide this up into an array. So fourths going this direction, thirds going this direction. And now I can fill in my gaps. So if I use my counters again for my 1/4, I'm going to fill in 1/4 going across, because my rows are my fourths, and my columns will be my thirds. So I fill in my column for 1/3 full. So now I've got 1/3 of my grid filled in the column, and 1/4 of my grid filled in my row. The only thing I need to do is I need to move this one that's sharing a box into its own box, and now I can see how many I have. So altogether, I've got 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7 out of 12. So my result would be 3 and 7/12. Again, if we were going to do this the traditional method, we would turn these into improper fractions. So 5/4 plus 7/3. We'd find a common denominator of 12ths and find our new improper fractions that way. Then we would add them together. We'd have 43/12, and when we reduce this to a mixed number, we would again get the same 3 and 7/12 that we got with the model. So the model again helps us with the common denominator. It also helps us see the math that's happening, how we're combining these fractional parts into a new fraction that looks different with a different denominator.